Welcome to the October edition of the openEuler Monthly Bulletin. We're delighted to bring you an update on the latest advancements, including key activities, project progress, and exciting new features that have marked this month. Let's dive into the major highlights from October. As of October 31st, 2024, the openEuler community has grown to over 3.64 million users, with a total of more than 192,300 PRs and over 102,700 issues generated. The community now includes 1,813 organization members, with 38 new members joining this October. Now, we would like to share with you the community highlights from October. On October 19th, the 5th China Cloud Computing Infrastructure Developer Conference was held in Beijing. At the event, openEuler technical experts introduced the recent developments and future plans of the community and engaged in the free discussions with developers on-site. On October 25th, the openEuler meetup was held in Hangzhou, focusing on operating system security. The event brought together members from the openEuler Security Committee and Security Facility SIGs, as well as technical experts from various organizations to share their insights. The highlights included security governance strategies, innovative technologies, and practices of openEuler releases. Also, the openEuler user group in Hangzhou was established during the meetup. On October 26th, the openEuler SDS meetup, co-hosted by the openEuler community and China Unicom Digital Tech, was held in Beijing. The event invited industry experts from different enterprises, including Lenovo, Intel, TaoCloud, China Unicom Digital Tech, and Huawei, to share valuable insights and practices about distributed storage technologies, covering SPDK, Ceph Crimson, Fast Block, high-performance all-flash architecture, and more. On October 30th, the second openEuler Ecosystem Conference was held in Changsha, Hunan. The conference brought together visionaries from across the supply chain, including partners, operating system vendors, ecosystem innovation centers, users, and universities, aiming to advancing the openEuler ecosystem. Powered by foundational technologies and a robust ecosystem, our open source industry is poised for remarkable growth. During the openEuler Technical Committee meeting in October, the following 4 projects have been approved to be created: OpenSCO, Como, Levy Web Rendering Engine, and openHigh-TLS. Initiated by Peking University and the PKU Changsha Institute for Computing and Digital Economy, the OpenSCO project aims to build a computing center platform for computing networks. By simplifying cluster software deployment and unifying platform management, it lowers user barriers, ensuring easier resource management and accessibility. The Como project is a functional safety middleware developed in CPP, which will be maintained by the openEuler Embedded SIG. Then, managed by the openEuler Desktop SIG, the Levy Web Rendering Engine project is planned for future integration into the embedded releases. Lastly, the repository for openHigh-TLS open source cryptography library will also be created and maintained by the Security Facility SIG. Additionally, the Standard Formulation and Certification SIG was approved to be established during the meeting for standardization and certification work. Besides, the Rust SIG has been merged into the Compiler SIG to enhance the maintenance of Rust-related packages. Next, let's dive into the technical progresses in October. Recently, One OS of China Mobile IoT, in collaboration with openEuler, launched an innovative dual-system AMP solution. This solution utilizes multiple cores on a single chip to independently run different operating systems, such as Linux and RTOS. It allows for efficient task allocation and processing, enhances system performance and stability, supports complex computing applications, and reduces hardware costs. In October, some repositories for new open-source projects have been created. Developed by Killensoft and maintained by the openEuler Storage SIG, Store Prototrace is a latency analysis tool for I/O events entering the ISCSI protocol driver layer based on libbpf. The support for LUN latency statistics will also be incorporated in the following updates. Compared to traditional tools like BlockTrace, Store Prototrace offers more precise measurement of I/O latency data at various stages of the ISCSI protocol driver layer. The upcoming LUN support will further enhance the tool's analysis capabilities, helping users optimize performance at different stages of LUN processing more efficiently. Then, initiated by Union Tech and maintained by the SDS SIG, the Gluster FS dashboard project aims to provide Gluster FS users with a visualized interface for efficient operations. Gluster FS is a scalable network file system designed for data-intensive tasks, such as cloud storage and media streaming. It integrates disk storage resources from multiple servers into a single namespace, enabling efficient resource scheduling and allocation. Since Gluster FS lacks GUIs, Gluster FS Dashboard was designed to offer comprehensive interfaces and optimizations. The innovative and efficient design of Gluster FS Dashboard is not merely about replacing command line operations with UIs, but instead introduces a complete cluster management strategy covering node and storage device detection, host CRUD operations, volume management, and more. This new tool significantly enhances the efficiency of building and using Gluster FS clusters while lowering operational and maintenance barriers. AI-enabled compiler-driven program optimization project has also been created in the openEuler community and is expected to be included in the openEuler 24.03 LTS SP1 release. The ACPO is designed to integrate machine learning models into compiler frameworks and provides relevant tools to facilitate model usage in compilers. ACPO has the following features, includes tools for training, inference, and feature quality control, simplifying the integration of machine learning models into compilers. Decouples models from the framework, allowing users to design and train models tailored to specific tasks. Offers a set of standard interfaces, ensuring models be seamlessly adapted for inference within the compiler with matched input or output formats. Provides two adaptation methods, which are ahead-of-time and real-time inference, along with example models. The VLLM project, maintained by the openEuler AI SIG and developed by Large Model Systems Organization of UC Berkeley, is an open-sourced high-performance inference framework for LLMs, supporting deployment of LLM inference services on various AI acceleration hardware. openEuler plans to add support for Kunpeng ARM servers and CPU-XPU heterogeneous inference acceleration. VLLM introduces advanced technologies like page detention and dynamic batching for foundation model inference and will continue to adopt the latest advancements in model acceleration. With the increasing adoption of high-bandwidth memory and SoC packages for HPC and AI and other scenarios, the high failure rate of HBM chips poses challenges, such as SoC or system board returns, higher maintenance costs, and reduced customer satisfaction. The HBM Predictor project, initiated by Xiamen Key Laboratory of Intelligent Storage and Computing at Xiamen University, analyzes HBM failures at different levels, such as time, space, and environmental conditions, identifies the correlated factors causing HBM failures, and assists in generating features for failure prediction. With multi-level failure predictor, HBM Predictor trains failure predictors at the row, column, bank, and server levels based on input features derived from HBM historical error logs and their cross-level correlations. It also enables flexible window adjustments to account for differences in HBM failure patterns across clusters, HBM generations, and workloads, thereby improving prediction accuracy. To achieve online HBM failure prediction, HBM Predictor deploys pre-trained models for real-time prediction via error events or periodic mechanisms, allowing timely identification and forecasting of potential HBM failures. In addition to the repositories created, we have other technical progress to share with you. An open-source promotion plan of openEuler, libguestfs support for custom configurations on openEuler virtual machines was completed and was merged into the upstream community. libguestfs is a tool and a library for accessing and modifying VM disk images. The virt Customize command line tool from libguestfs tools can be installed on various Linux distributions and used to customize a VM or disk image by installing packages, editing configuration files, and setting time zones. The virt Customize command has been enhanced based on openEuler 24.03 LTS, now supporting custom configurations for openEuler VMs in both RAW and QCOW2 formats. As digital transformation accelerates, enterprise IT architectures face new challenges and opportunities. LLMs are being increasingly integrated into IT infrastructure as they rise. In response, openEuler is evolving towards native intelligence and has launched openEuler Copilot system. This platform empowers intelligent tuning and O&M for OSs, further advancing the community's AI for OS capabilities. By the end of October 2024, a total of 2,291 hardware and software products were certificated as compatible with openEuler. This includes 1,546 applications, 577 hardware components, and 168 OSs, among which 46 applications, 8 hardware components, and 6 OSs were added to the compatibility list in October. In October 2024, we published 92 security notices and patched 255 vulnerabilities. You can find the security announcements on the openEuler official website and install the vulnerability patches in time. That's all for this openEuler monthly bulletin. We would like to extend our gratitude to all members, developers, and contributors for their support and contributions. Please stay tuned for more updates and news in the openEuler community.